We need to add a lot more rails, a lot more struts, a lot more braces. We're going to start off with the Raker rails. Raker rails, again, it's going to give me a cheat sheet. We're going to build a double Raker as a 60-degree Raker. So I'm going to use my bottom table for what I need to do. My 10-foot insertion point is going to give me about an 11-foot Raker. My 18-foot is going to give me around about a 16-foot Raker. We're going to start off with the Raker rails. We're going to build this. We're going to put 3 rails together to give us our height we need for our 2 insertion points. So with our 3 rails together, we're going to take a look at the sole strut and the 2 insertion struts. So my sole strut is going to go in my bottom hole if I haven't got any debris against the wall. That's going to be my insertion for my outer Raker. For my inner Raker, I'm going to need my rail junction. That's going to come up to 6, 7, 8. We're going to set up our outer Raker, then our inner Raker. Now my 610 strut's going to go in. Then we're going to come in and build our inside Raker. When using this rail junction for my double Raker, the one with the word sole goes to my lower Raker, because that way everything's in line. This then will come across so a brace can hit the outer Raker. I'm going to have a junction on my inner Raker. To join the outer Raker to the inner Raker, we're going to put a 2-foot extension with our smaller B23 brace. With our 2 legs set, we're ready to carry the double Raker into place. With the double Raker leg in place, now's the time we're going to pin. We're going to put 2 pickets in the bases for the small Raker, inside Raker. Then we're going to put 2 pickets in the base for the outside Raker to hold it in place. In that time, the rails are going to be attached to the wall with either lag bolts, concrete anchors, or whatever you've got to anchor that to the wall with your rebar, things like that. When the pickets are in place and the wall anchors are in place, we need to pressurize the system. Again, we don't want to pressurize it too much because of the wall. It's up there for a reason, that's because the wall is compromised. So we can come in with the Paratech hammer, come up to the collar and pressurize the collar. When we pressurize the collar, when it's all in place, it tightens that Raker into the wall. We can do both outside and inside Rakers, as well as the sole. By doing that, it pressurizes every part of this Raker to the wall. Now we build the second one alongside, and we brace the Raker.
The door frame. With the header, I'm going to take the U-channel and I'm going to place it directly in the center of this header. You'll see the U-channel. On either side, there's nail holes. We're going to go ahead and place nails in those holes, bend them over so that it's controlled. It won't fall out as we go to place it in. Now we've bent those nails over. That controls that U-channel, prevents it from falling out on us unexpectedly. I'm now going to take the Paratech strut with an extension. The more barrel we still have inside there is going to be better for the strength. So I take a small extension. I'm going to slide it into the header, locks it into place. After that, we've got our 6x6 rigid base set up. We're going to take our header and sole, make the attachment. Center it up over the load. We'll raise it into place. Spin the collar. Now we have our strut capturing the header. At this point, we want to step back and make sure this strut is lined up perfectly straight up and down. Any type of movement off center kind of promotes shifting that load. What we're going to do is, you notice we have a void here in the top of our header. That needs to be backfilled so that pressurization is done evenly across the entire spot. How we do that? 2 wedges. So now we've captured that void. We've got tight here. That captures the load. Last thing we have to do is pressurize the strut. We're just going to give a minimum pressure just so it doesn't fall out. We spin the collar. It's nice and tight. If you look in the use our manual,
we want to make it stronger, then we need to cross braces. There's a few ways we can do this. 1, we can come in with our 2x6, go ahead of the sole, each strike to create the X. 2, we can put our clamp clevises on you. We'll put the B57 in between. 3, with pre-construction, if we know we're going to cross brace, we can put our Raker junctions on you. I'll put our B57 in between. And the last option, we can come in with our nailing pads, put our nailing pads on the struts, and put a 2x6. So here's your 2 posts vertical. It's capturing 4 joists. The post, which is the strut, is under 1 floor joist, which marries 4 foot apart to the other 4 joist. I've got a brace, B57 brace in the diagonal. The rescue guardian is in line with the strut to monitor any movement in this building. So that's your finished.
Rail latches, we'll place them in there 4 foot apart, which was done by the predetermined holes that are 12 inches apart, which makes it nice and easy for us, again, with no measuring. So we're going to place the 4 or 6 strut in now. That's going to be towards our back, because if you look at our collapsed area, it's higher on the back side than the front side. Now we've got it pre-assembled on the outside. All we have to do is take it into the collapsed area, stand it up, match the floor, and then pin it. After we pin it, we'll pressurize. When we get in there, I'll start talking about some advantages of why the mechanical shores will make it a safer, quicker area for you to operate when you're building a more permanent woodwork. Second leg of the slope floor shore. Now we'll carry it, set it into place, and begin our cross bracing. So we have the second leg in. You notice we braced it in opposite directions, so when it becomes a total package, all the directions are covered as far as tension and compression is concerned. When we look up at the top, as we discussed earlier, we would need to pin this above and below through these holes. That way we can get true pressurization. If we don't do that, it's going to slip in either direction. I'm placing these clamp and clevises on here so that when we put our diagonals in, we'll have the total system package together. So we won't be using just one side, we'll be using both sides together similar to a lace post. This shore can go up to 8 feet wide. So now we've completed our slope floor shore. We've got bracing in both directions, going opposite from each other, which controls tension and compression in all directions. This allows us to build a more permanent wood shore around on the outside of this, so we stay safe the entire time.
First thing, I'm going to come in on the tank. I'll put the long shore nearly vertical to stop the crush on the big vehicle over the small one. Then I'll come in with the stabilization of the big vehicle. And I'll bring in the chain. Take the slack out of the chain. You're going to stake the base. Stake should be driven in 2/3 of the way for demo purposes. I'm just going to take them in about 6 or 8 inches. Make sure my stabilization is tight. Then connect your 2 hoses to your 2 stabilization struts. Connect the hoses to your VSK controller. Be sure to spin down the collar on the vented coupling, otherwise it will leak. Open up your cylinder. Let air go to the struts. Open up your controls. Just set and forget. Then going to set up to stabilize the car. First what I'm going to do is tie the suspension down on the car. Attach in the ratchet strap. Attach to the top of the wheel. Insert your 4x4. Take out the slack. Then you're going to ratchet the suspension down. What the 4x4 does, it keeps the belt off of the glass. That way, the belt will not get cut by broken glass, or if the glass is intact in the back, the belt will not pressurize and break the glass unexpectedly. Now the tank is stabilized, I can come under the tank, then we'll do the same in the front, and tie the suspension on the car, so the car actually stays as low as it can to the ground, and feed some belt out. I don't need to use the crib in on this side. Now the car's down, now we can set up for our lift. We're coming with a hydrofusion, coming with the head. The hydrofusion we need it around about 80 degrees. That's why it's actually lifting. Then we need to stake the base. Attach the pump, make sure the pump is open before you attach. When we do the lift using the hydrofusions, we need to go simultaneously. Line of sight is always the best. You ready? Okay, let's go. We really need another 2 firemen to work the stabilization. Okay, you're only going to lift as high as you need. Lock all your...
Always keep innovating and making the best tools to save lives. Now it is time to meet the future of rescue. Are you ready?
Are you ready?
Are you ready? Are you ready for the future?
Paratech is proud to introduce the Rescue Guardian, the most advanced monitoring system for technical rescue available. The Rescue Guardian was created to keep you safe. One device that monitors load, vibration, and incline. In an earthquake rescue scenario where aftershocks are a concern, the Rescue Guardian is there to ensure the safety of the rescue personnel and on-scene victims, and it will monitor any seismic activity. Vibration and incline alarms can be combined. The Rescue Guardian can be clamped onto any object to be monitored, and you can remotely monitor up to 10 Rescue Guardians on one smart device simultaneously. In vehicle stabilization, unsafe inclines or too heavy loads can have disastrous consequences. The Rescue Guardian monitors the load and incline of what is being lifted, giving you real-time data on the rescue at hand, and alerts you if it's unsafe. The Rescue Guardian is here to protect you in structural collapse rescue, standalone, vehicle stabilization, trench rescue, and any rescue scenario where monitoring load, vibration, or incline is crucial. In a raker, all alert functions are on. Load change, monitoring any shift in the load transferred through the raker system. Vibration alert, warning you of seismic activity and incline data warning, and informing you of any structural shift. The Rescue Guardian, the most advanced monitoring system for technical rescue available. The future of rescue is here.